Hello, dear students. Welcome to YRK'S Race Academy, Bangalore. In this class, I would like to start the discussion about aldehydes and ketones topic with a detailed explanation of the important points and synopsis, followed by some important chemical equations as well as the most important reagents useful for preparation of aldehydes and ketones. Okay, let us start the topic. Okay, topic is aldehydes and ketones. Aldehydes and ketones. So in this, first of all, we would like to discuss about the important topic of aldehydes, ketones, and its competitive angle. Okay. So the point we are going to discuss, these are also called as carbonyl compounds. Carbonyl compounds. And they'll be having a carbonyl carbon linkage. If we have alkyl group attached to one of the valence of carbon, that is nothing but aldehyde. If we have hydrogen is there, that is aldehyde here in this place, where both are alkyl groups are there, that is ketone. This is what a general idea of aldehydes and ketones. So carbonyl carbon is detailed information in the basic classes we have observed. So when we have RCHO is there, that we will call it as aldehyde. When we have RCO or same or different alkyl groups are there, that is called as ketone. And a simplest aldehyde is formaldehyde. That is both the valences of this carbonyl carbon satisfied by hydrogen, that is nothing but formaldehyde. If we have one alkyl group like methyl group is there on the carbonyl carbon, that we will call it as acetaldehyde. Acetaldehyde. And if we have both the groups, alkyl groups or methyl groups are there, that we will call it as acetone in the discussion. So these are the general important formula for this aldehydes ketones, and we will also learn about further different aldehydes and ketones in detail. So let us start about the topic of aldehydes ketones with directly for competitive angle. The point we're going to discuss is methods of preparation. This is nothing but we're going to discuss about methods of preparation of these aldehydes and ketones. First of all, we'd like to learn about these methods of preparation from alcohols. That means mild oxidation of alcohols. That point is called as, that important preparation is called as mild oxidation of alcohols. Mild oxidation of alcohols is the topic. That means is the methods of preparation of aldehydes or ketones. So in this, what will happens is nothing but we are going to talk about an important information. That is, for example, if you take alcohols, general formula is RCH2OH. These alcohols on mild oxidation gives carbonyl compounds. Means we have an essential oxygen we are showing on the arrow mark. This RCH2OH will be converted into RCHO. So here RCH2OH is converted into RCHO. RCHO is nothing but carbonyl compound aldehyde. In the similar fashion, when we have another kind of alcohol, that is RCH R, like this. That means first equation we have taken is primary alcohol. Now in this we are taking a secondary alcohol. When you take primary alcohol, we got aldehyde. Do remember, when you have taken the mild oxidation of primary alcohol, we got aldehyde. When we have taken secondary alcohol, the mild oxidation is going to be converting secondary alcohol into ketone. Ketone is RCOR. So this is called as ketone. That means mild oxidation of alcohols, either primary alcohols or secondary alcohols. Primary alcohols gives aldehyde and secondary alcohols gives ketone. This is the important process of the preparation of these aldehydes and ketones, carbonyl compounds from alcohols. Okay, we're going to see exactly what kind of these reagents are required for us to do such type of mild oxidation process. Means we require the oxidizing agents here to understand this conversion of alcohols into carbonyl compounds. Means there are some respect to oxidizing agents are there. The respect to oxidizing agents will be noticed now. That means the various oxidizing agents required for this process we will take. The one example we have, that is potassium dichromate, that is K2Cr2O7, an acidic medium in cold condition that will convert these alcohols into aldehydes. Another thing we have, this is called as a Jones reagent, that is CrO3H2SO4. CrO3H2SO4 and acetone medium. We will call this is nothing but Jones reagent. So this reagent is also possible, is also a possible reagent for this conversion of alcohols into ketones, aldehydes and ketones. Fenton's reagent, another one is we have that is nothing but Fenton's reagent. So this Fenton's reagent is nothing but FeSO4, which is in H2O2 medium. Other you can also Sarret reagent. Sarret reagent. The Sarret reagent is nothing but a pyridium chlorochromate. That is a PCC. Sarret reagent is PCC. Pyridium chlorochromate. Or else we have PDC. That is a pyridium dichromate. PDC is nothing but pyridium dichromate, which is nothing but CrO3 plus pyridine in water. CrO3 plus pyridine in water. That is also an important this one oxidizing agent. Not in this one, we have DMSO is there. DMSO in carbonyl chloride, in tetraethyl amine. Tetraethyl amine. We have so many other reagents are like manganese dioxide in CCl4, or that is in acetone. CCl4 are in acetone. That is also one important thing. Usually we will take another important reagent, that is nothing but copper metal. Copper metal at 300 degrees Celsius or silver metal at 300 degrees Celsius. Silver at 300 degrees Celsius also converts these alcohols into carbonyl compounds. Else finally we have one more important thing is the aluminum tertiary botoxide in acetone. Aluminum tertiary botoxide in acetone is another important reason to convert this alcohols into this what we call carbonyl compounds like this. This is the list of important various oxidizing agents which are also called as mild oxidizing agents, converts alcohols into carbonyl compounds. This is important reactions. Reaction reagents. These are important reagents. Let us move to the next thing. We have the next important thing is from calcium salts of carboxylic acids. From calcium salts of carboxylic acids. From calcium salts of carboxylic acids. Here, calcium salts of carboxylic acids means if you take formic acid, HCOH, its calcium salt is called as calcium formate. Its calcium salt is called as calcium formate. So in this, if you remove hydrogen, we will get formate ion, and calcium valence is 2. That's why the formula will become Ca HCO twice or HCO twice Ca. Is called calcium formate. This we can take it. Or else, if you have the calcium salt of other carboxylic acids, that means other carboxylic acids means very simply, usually we have carboxylic acid, carboxylate ion is RCOO. Other carboxylate ions, ion RCO, if you take, this is also 2 times, you'll write RCOCA, RCO twice, or RCO twice Ca. This is also another kind of carboxylic acid salt. First one we have taken is calcium formate. So what is calcium formate? That is HCOO twice Ca. And this calcium formate, which is subjected to the distillation process. Subjected to distillation process. That we'll call it as dry distillation. That phenomena we will call it as dry distillation, and upon this dry distillation, this calcium formate is said to give formaldehyde, HCHO and CaCO3. So what is HCHO? It is called as formaldehyde. Okay. Suppose you have taken CH3 COO twice Ca. I'll call it as calcium acetate. Here, the first one we have taken is calcium formate. Calcium formate. And now we are taking, that is CH3 COO twice Ca. Nothing but calcium acetate. Carboxylic acid is calcium acetic acid, and its salt is called as calcium acetate. So when we have taken this calcium acetate, what will happen? Let us see. The same phenomena, dry distillation, will lead to the formation of symmetric ketone, that is CH3 CO CH3 plus CaCO3 CaCO3. So this is what the calcium salt of other carboxylic acid. Here other carboxylic acid I have taken is acetic acid. So acetic acid salt is nothing but calcium acetate I have taken. So this is the representation. For this, what is the general representation is nothing but, what is the general, in generally how we will represent is nothing but, in generally we will represent this equation is calcium salt of other carboxylic acid, will write it as R COO twice RCO twice Ca. This is calcium salt of other carboxylic acid. If it is subjected to distillation, dry distillation, we'll be getting RCOR plus CaCO3, calcium carbonate. So when you have taken calcium acetate, we got the compound that is nothing but acetone, that is ketone. And RCOR is general formula of ketone here in this equation. Okay, so like this, we can also prepare this compound that is nothing but the ketone. Suppose you want to prepare something other than this. Something other than this means let us see. You want to prepare formaldehyde. You want to prepare formaldehyde means first equation. Or else you want to prepare acetaldehyde, then you should take the mixture of carboxylic acids. Mixture of carboxylic acids of calcium formate and calcium salt of other carboxylic acid. So let us see that. Here, what we have done here is nothing but, in the first equation we prepared formaldehyde. If you wish to prepare acetaldehyde, is a carbonyl compound, by this method, you should go with the mixture of calcium salts of carboxylic acid. So, mixture of calcium salts of carboxylic acids. If you take, what will happen? Suppose you have taken calcium formate like the first equation, only you will get formaldehyde. But what I am doing is mixture of calcium salt of carboxylic acids means I am taking an important compound like calcium acetate I am taking, that is CH3 COO twice Ca. What is the first one I have taken is calcium formate. The second one I have taken is nothing but calcium acetate. And in this mixture, I can say one is calcium formate, another is calcium acetate. Doing the same process. Same process means dry distillation. We are going to get an important compound. That compound we will call it as aldehyde. What's the compound? Aldehyde. That is CH3 CHO. Aldehyde, you will get 2 moles of this one, and rest of the other one is nothing but 2 moles of calcium carbonate. See, you can see in this one, carbonate, CO3, CaCO3 separated out. The major product we obtained here is nothing but acetaldehyde. Also, we'll call it as ethanol. IUPAC's name, ethanol. Okay, IUPAC. If you wish to take the different kinds of groups of this other calcium carbonate, other calcium salts, carboxylic acid salts, both are other calcium carbonate salts, general form. If you take, then you will be getting ketones. Like I said earlier, if you take R dash COO twice Ca is a nothing but calcium salt of other carboxylic acid with the calcium salt of another different kind of carboxylic acid salt. Then if you take, you're going to get a ketone. Upon this dry distillation, you will get RCO or dash, you will get 2 moles, you will get. The rest of the other one is nothing but 2 moles of calcium carbonate is common, okay, in this process. So here RCO or dash, what you have obtained, which we will call it as ketone. Hope I understand. When you want to prepare a ketone, you have to take the different carboxylic acid calcium salts mixture, or you want to prepare acetaldehyde, you have to take calcium formate and calcium acetate only. When you want to prepare formaldehyde, then you have to take calcium formate in this process for the dry distillation phenomenon. Okay. Let us go to the another kind of idea in this method. What is another kind of idea is, you can also prepare these ketones from carboxylic calcium salts of dicarboxylic acids. How it is? Let us see. The point is nothing but you can prepare the ketones from calcium salts of dicarboxylic acids. Dicarboxylic acids. Calcium salts of dicarboxylic acids. Okay. Here, actually, this method we are going to introduce. We're going to introduce whenever we want to prepare cyclic ketones. This method we are going to prepare for cyclic ketones. The ketones are called cyclic ketones. Okay. So what kind of ketones you are going to discuss in this method is nothing but cyclic ketones. The point is that when you have calcium salts of dicarboxylic acids are there, they definitely forms this type of cyclic ketones. I am taking a dicarboxylic acid calcium salt like this. This is ion of that dicarboxylic acid. Okay, with calcium. So this is a calcium salt of dicarboxylic acid. There are 2 COOH groups should be there and removed hydrogens. we got the dicarboxylic acid salt ions and we have mixed with the calcium. The formula, upon heating, after removing calcium carbonate from this reactant, we'll be getting a cyclic compound. We'll be getting a cyclic compound in which we'll be having a double bond with oxygen as ketone. As you know, this will simply we can represent as like this. So this we can call it as cyclic ketone. Cyclopropanone. Its name is cyclopropanone. Hope you understand. Next, we're going to talk about hydroboration method. Next method is hydroboration method. Hydroboration method is oxidation method of alkynes. The method is called as by hydroboration oxidation of alkynes. Actually, in this method, alkynes whatever are there upon oxidation will are subjected to hydroboration oxidation using H2O2. In this method, you will get carbonyl compounds. So or C triple bond H is nothing but alkyne. This is an alkyne, and this alkyne is subjected to this hydroboration oxidation method in the presence of H2O2 medium in basic medium. It will give the aldehydes, this is or CH2 CHO. This we will call it as aldehyde. Whereas in this method, we are going to talk about a terminal alkynes are there. Suppose terminal alkynes are there. Definitely they will give aldehydes. This is an important point to be noted. That is, we have taken terminal alkyne. So terminal alkyne, what it has given is nothing but it has given aldehyde to us. Terminal alkyne is giving what kind of compound? Gives aldehyde. Whereas non-terminal alkyne, if you take in this method, you have taken non-terminal alkyne. So that kind of non-terminal alkynes will give the compound ketones. Do remember, they will give ketones. And the equation what we are showing here is going to be taken place in the presence of this hydroboration oxidation method with addition of borane to carbon-carbon double bond. So this hydroboration is taking place when we are adding, so adding BH3. What is that? Adding BH3 to carbon-carbon double bond in this method. Okay, that is one simple method, but elaborately it will be discussed again and again in the competitive exam. So this is what by hydroboration oxidation method of alkynes. So hydroboration definitely carried out by using bulky boranes. Here that's why we are not clearly mentioning, but which type of boranes will be taken? What type of boranes? Hydroboration. Hydroboration is definitely said to be carried out by using bulky boranes. Bulky boranes in this. The bulky borane general formula is Si-A2BH. So that also you can use. So that's why simply what you will write on the arrow mark in the exam is hydroboration oxidation. So what is the bulky borane general formula you will write is Si-A2BH. That is bulky borane formula, general formula. Okay. This is an important reaction when it comes to the preparation of carbonyl compounds from alkyl compounds, alkynes compounds. Now we're going to talk about the properties of carbonyl compounds. Properties of carbonyl compounds. We're going to talk about properties of carbonyl compounds in the exam. In particular, the properties of carbonyl compounds, first we're going to talk about reaction with ammonia. Reaction with ammonia. Reaction with ammonia. As you know, ammonia is NH3. And aldehydes ketones usually react with ammonia to form respective amines. This reaction definitely gives an important compound called as imines. Imines. Usually formaldehyde if you take in this process, formaldehyde is nothing but HCHO. If you take formaldehyde with NH3 ammonia, you should take 6 moles of this formaldehyde and 4 moles of ammonia. You will be getting a compound called as urotropine. That is hexamethylene tetraamine. Methylene is CH2, hexamethylene means 6 will come like this, and 4 nitrogen for 4 ammonia also join with these methylene groups. This CH2 6 times N4 plus 6H2. The compound what we obtained here, simply we will call it as hexamethylene tetraamine. Tetraamine. Also we will call it as urotropine. Urotropine, important name for this one. And this urotropine structure, if you see, it looks like a cyclic one. How the cyclic is, methylene groups are there, and that methylene groups alternatively join with the nitrogen of ammonia like this. And in the middle also will be having one nitrogen that join with another nitrogen by again methylene groups. Okay, like this, this urotropine structure is there. Actually, what is the importance of this one is, it is nothing but an important compound for the preparation of RDX. for the preparation of RDX in the presence of nitric acid in concentrated state, concentrated nitric acid if you take. This urotropin is said to be giving cyclonate, is also another important cyclic compound of nitrogen atoms in the ring joined with NO2 groups. So cyclonate, its name is cyclonate. This we will call it as RDX, research development explosive or royal demolition explosive. This is an explosive. So we have started with the reaction of ammonia. We got hexamethylene tetraamine, urotropin, a cyclic compound, and this is subjected to nitration. That is given cyclonate, which is also known as RDX, research development explosive. That is cyclonate. That is the importance of this reaction of this formaldehyde. What is SiO2 taken? Formaldehyde with ammonia. Whereas if you take other kind of ketones, like the reaction with acetone, we'll see the ammonia reaction now. That is reaction of acetone with ammonia. Reaction of acetone with ammonia, if you see. Actually, what is acetone? CH3, COCH3. This is acetone. You take this is 2 moles with ammonia NH2, NH3. This acetone is said to be giving a compound which is called as diacetone ammonia. Is addition product, that is diacetone ammonia, will be getting NH2 at one of the valences of this carbonyl carbon. After the reaction, that is become CH2COCH3. Okay. So diacetone ammonia, this addition compound is known as diacetone ammonia. Diacetone ammonia. If you can check this, you can also understand that there are around 6 carbons are there. Here also 6 carbons in the product obtained, that's called as diacetone ammonia. Another one. We're going to talk about the reaction with phosphorus pentachloride, another important reaction of carbonyl compounds. Usually carbonyl compounds reacts with PCl5, they give geminal dihalides. For example, if you take acetaldehyde, CH3CHO, with phosphorus pentachloride, and carbonyl oxygen is there in the carbonyl compounds, that will be replaced by 2 chlorine atoms. Then one oxygen place you will write 2 chlorines. You will get answer, that is CH3, CHCl2. Plus rest of the compound is phosphonyl chloride, POCl3. So this CH3CH2, CH3CHCl2 you got is called as geminal dihalide. Geminal dihalide. Also, you can call it as ethylidene chloride. Exact name you want to write is ethylidene chloride. Similarly, if you take acetone, CH3, COCH3 with phosphorus pentachloride, then the reaction leading to give CH3, Cl2. So in the middle carbon, we have two chlorine atoms. This is called as propylidene chloride plus POCl3 will be formed. This is also geminal dihalide because on the same carbon, there are two halogens are present. This is also called as geminal dihalide. Exactly, you want to write the name, that is called as propylidene chloride. 2,2 dichloropropane is the name of this compound. Second equation, product, main product. So first equation we got 1,1 dichloroethane. Second equation we got 2,2 dichloropropane. So these are called geminal dihalides. Okay. Let us see the next one. That we will call it as important reaction. Some recapitalizations of Aldol condensation we will see here. Recapitalization of Aldol condensation. First of all, we would like to learn what is Aldol condensation reaction. Once again, carbonyl compounds actually, they should contain important condition is alpha hydrogen. So what is the statement is? Most important question for the exam, both board and competitive, that is Aldol. Statement I am writing, carbonyl compounds containing alpha hydrogen, they'll undergo condensation. They will undergo condensation in presence of a base, to give beta hydroxy. The compound, final compound name should be beta hydroxy aldehyde, or ketone, that is known as aldol. That is known as beta hydroxy aldehyde or ketone is called as aldol. So once again, statement is carbonyl compounds, they must contain alpha hydrogen. They'll undergo condensation in presence of a base to give beta hydroxy aldehyde or ketone. Actually, when you have taken this process, you should take reaction between two aldehydes or ketones, or one aldehyde or one ketone. Suppose you have taken a kind of aldehyde like acetaldehyde. If you take acetaldehyde like this, 2 moles of acetaldehyde you are taking, 2 moles. Okay, when you're taking 2 moles of acetaldehyde in the presence of base, reaction completes and it will give a compound called as beta hydroxy aldehyde. So this is called as aldol. Suppose if they are given a condition in the exam, that is The reaction is catalyzed, which is called as acid catalyzed aldol condensation. Then what might be the product? Okay. What is the product? So if you are observing this process first time, you should be very careful. So the process is nothing but acid catalyzed aldol condensation. Acid So if this aldol condensation reaction undergoes in the presence of an acid, then that will call it as aldol condensation reaction, acid catalyzed reaction. In this, you will take HCl, dry HCl in this reaction. You're getting a product here, product name we are writing, that is Mecitline. What is the product name? That is Mecitline. When we have taken acetone only, this will takes place. Acetone is nothing but propanone, like this. It will be there. You take one acetone like this, another acetone in a linear manner. If you take for representation only, then you'll be just removing the water molecule, and that is going to happen in the presence of hydrochloric acid, abstraction of water molecule leading to the product. The product will be like this. So we'll be having a water removal here takes place. So a double bond between two carbon atoms will be established, and you'll be getting like this. Actually, this compound common name is Mecitline. Mecitline oxide. Its name is Mecitline oxide. IUPAC name, if you write, this is nothing but 4-methyl pent 3-ene 2-1. That's the IUPAC name of the Mecitline oxide. This is a kind of process called as aldol condensation reaction. If this is taken place with the excess of acetone, what is the product? Asked. Suppose acid catalytic reaction, formation of methylene oxide obtained here. Acetone reacts with DiHCl, the product is methylene oxide. But in the exam, if they are given something differently, that is acid catalyst reaction, excess of acetone if you take, then this can be called as formation of furon. The phenomena, the process is called as acid catalyzed aldol condensation reaction. Aldol condensation reaction. And in this condensation reaction, we're going to see the formation of, furon. Compound name is furon. So it is going to obtained when we have acetylene, when you have acetone, excess of acetone reacts with HCl. Means you take 3 moles of this acetone like this. So first acetylene molecule, acetone molecule will be taken like this. Second acetone molecule, as usual, in a linear manner you will take. So when we have taken 2 acetone molecules, you got methylene oxide. If you take 3 acetone molecules in this manner, you will be getting, you will be removing 2 moles of water, definitely 2 moles of water molecule you will be removing. Here 2 moles of H2 will remove in the presence of HCl, which should be dry HCl. The product will be formed by the removal of 2 water molecule. You can just observe here 1 water, here 1 water you will remove. The product will be looking differently. That is, double bonds will come in this manner. Middle acetone will be providing oxygen to the structure, and terminal groups are methyl groups to this double bonded carbons. And this we will call it as 4-on. The compound name we will call it as 4-on. It is also a ketone. Its IUPAC name, if you see, it is given as 2,6 dimethyl. We have 7 carbons are there in this. That's why we call it as hept. 2,5 diene 4-1. This is IUPAC name of 4-on. Hope you understand. When they ask acid reactized Aldol condensation reaction, the formation of 4-on takes place only when we have taken excess of acetone. Excess of acetone is the wording is important. Excess of acetone reacts with the dry HCl to form compound known as 4-on. This is one of the most important Aldol reactions. So if you continue the acid catalyzed aldol in a different manner, aldol condensation reaction, whereas another kind of compound is also possible, that we'll call it as Mecitline. This reaction is called as formation of Mecitline. Here 3 molecules of acetone you will take, like the 4-on reaction. You will take concentrated H2SO4. What is the medium here is concentrated H2SO4. In this also we will remove water molecule, 3 water molecules from 3 acetone molecules. 3 acetone molecules, CH3, CO, CH3, like this. Suppose you want to mention exactly how this is present, I'll also show you. These 3 acetone molecules forming a cyclic structure. 1 acetone molecule is given like this, is taken like this. Another acetone molecule is taken like this. You just see how closely we are going to remove the water molecules, 3 water molecules. Another one we will take like this. You can observe here where and where we are going to remove water molecules. I'll show you. Here we will remove water molecule. Here we will remove water molecule. Here we will remove water. Total 3 water molecules we are going to remove in this one. After that, we're going to get a cyclic benzene ring type of structure that is called as Mecitline. Benzene ring will write, and methyl groups, 3 methyl groups present at the alternative positions on the benzene ring. This we will call it as Mecitline. Anybody ask the IUPAC's name? Its name is 1, 3, 5 trimethyl benzene. Trimethyl benzene. So this is our equation part of this lecture. So in this lecture, we have given you explanation about the preparation methods of carbonyl compounds. And after that, we have started discussing about given the chemical equations for the properties of carbonyl compounds, in which we have ended up with the Aldol, important Aldol condensation reaction. And this Aldol condensation reaction and its details will be carried forward, will be continued, explained in the next session also. So in this session, we have briefly understand what are the important chemical reactions of aldehydes and ketones and their properties. Okay. So I hope you understand this equation part and all given to you in this session. You can write the notes by following the class, this video, by keeping the video pause and writing the equations detailedly. And you can practice these equations for the competitive examination. And coming sessions, we will discuss important competitive examination questions also on the basis of this topic. Okay. Until have a nice day. Thank you.